Hello everyone. Let us discuss few problems in matrices and determinants. Let us see the question 1. If A and B are square matrices of order 3 where det A is given as -2, det B is 1, then we need to find out det of A inverse adjoint of B inverse into adjoint of 2A inverse equals to -k. Then the value of k is. Here are the options 6, 4, 8 and 2. Here the right answer is option C, 8. We can write as det of AB can be written as det A into det B. So based on that property, we can write as det of A inverse into det of adjoint of B inverse into det of adjoint of 2A inverse, which can be written as det of A inverse can be written as det A power -1 based on the property det of A power n is det A whole power n. Det of adjoint of B inverse can be written as det B power -2, and adjoint of 2A inverse can be written as based on the property adjoint of Ka is k power n minus 1 adjoint A, where n is the order of the matrix. We can write 2 square of adjoint A inverse, which we can simplify as 2 square 4. If we apply the property det of Ka is k power n det of A, we get 4 cube of det A power -2. By substituting the given values of det A and det B, we get the value is -8. So the value of k is 8. Let us see one more question. If the planes x equals cy plus bz and y equals to az plus cx and z equals to bx plus ay passes through a line, then the value of a square plus b square plus c square plus 2abc is. Options are 0, 1, 2, -1. Let us see the solution of it. In the given question, planes are having a common line, which means, you can observe this. These are the planes having common line of intersection. So we can conclude that the given planes having infinite number of solutions. Hence, the homogeneous equations having infinite number of solutions, then det A equals to 0. So we can say the given planes have a line in common, implies the given planes have infinite number of solutions, hence det A equals to 0. So by equating det A equals 0, we get the value of a square plus b square plus c square plus 2abc is 1. Next question, A equals to a matrix of order 3 by 3 is given and A inverse is given in terms of a square, a and I. Then we need to find the values of m and n. The options are 6, 11, -6, -11, -6, 11, 6, -11. Let us see the solution of it. Instead of finding a square A and verifying with the matrix A inverse, we can find out the characteristic equation of the given matrix, which is lambda cube minus 6 lambda square plus 11 lambda minus 6 equals to 0. And by the Cayley-Hamilton theorem, we can say every square matrix satisfies its characteristic equation. Hence, we can write as a cube minus 6a square plus 11a minus 6i equals to 0. So by pre-multiplying with A inverse on both sides, we get A inverse in terms of A square, A and I. So by comparing with the given question, M and N values are -6 and 11. Next question, let delta x be a determinant of order 3 by 3, which after expansion, it is given as a polynomial of degree 4. Then find the value of 5a plus 4b plus 3c plus 2d plus e is. Options are 0, 16, -11, -17. For solving this problem, we can apply the differentiation of determinant concept. Before differentiating the determinant given, we multiply the determinant by x. So we get ax power 5, bx power 4, cx cube plus dx square plus ex, which you get by deriving 5ax power 4, 4bx cube, 3cx square, 2dx plus e. And differentiating a determinant, we can do one column after the other. So which you get as differentiating the first column, x square derivative 2x, x cube derivative 3x square and x square derivative 2x, keeping the other two columns as it is. And next differentiating the second column, keeping the first third as it is, and at last differentiating the last column, keeping the first two as it is, we get this step. By substituting now x is equals to 1, we get 5a plus 4b plus 3c plus 2d plus e equals to minus 11. Let us see the next question. If A, B, C are three square matrices of same order such that B equals to C A C inverse, then C A cube C inverse is. Options are B, B square, B cube, and B power 9. Let us see the solution of it. B equals to C A C inverse. By post multiplying C, we get BC equals to CA. So we need to find out CA cube C inverse, which we can write A cube as A into A into A. So from this step, we can write CA as BC. So we get this. And next again CA, we can replace as BC. We get BBCAC inverse. And CAC inverse is given in the question as B. So by substituting that, we get B into B into B, which is B cube. So the right answer is B cube. Let us see one more question. The equations x plus y plus z equals 6, x plus 2y plus 3z equals 10, x plus 2y plus lambda z equals to mu have unique solution if. Here are the options. Let us see the solution of it. From the given equations, we can write the augmented matrix AD as this is the matrix A and this is the matrix D. So by applying the transformations, R2 implies R2 minus R1 and R3 implies R3 minus R1, we get these two terms 0. Okay, we arrive at this step. And by applying the transformation, R3 implies R3 minus R2, so making this term 0, so we get an echelon form in which number of zeros before a non-zero element is less than number of zeros before the non-zero element in the next. So we can say rank of AD, rank of A both equals to 3. So if lambda minus 3 is not equals to 0. Hence, if both the ranks are 3, we can say the given system of equations have unique solutions. Hence, to get the unique solution, lambda must not be equals to 3 is sufficient. Let us see one more question. Let n be a positive integer and delta r is given a determinant of order 3 by 3. We need to find out sigma r equals 0 to n of delta r. Options are 0, 1, minus 1 and n. So based on the concept of applying sigma in determinant, we get sigma of delta r as the first row includes the variables r, so we can apply sigma to the first row only. So which sigma of 2r minus 1 we can get as, by substituting the values from 0 to n, we get minus 1 plus 1 plus 3 plus 5 so on to n minus 1, which by adding n by 2 into sum to n terms of AP, n by 2 into A plus L, which you get n square minus 1. So sigma of it can be written as n square minus 1. And next element we get by substituting the r values nc0, nc1 so on ncn, which we know as 2 power n. So the next element will be 2 power n. And the next sigma of 1 r from 0 to n, so which you get 1 1 1 1 so on n plus 1 times. So 1 adding to n plus 1 times, which gives n plus 1. So we get the determinant in which the first row same as the second row. So based on the property, if two rows are identical, its determinant 0. We can conclude the value of given determinant by applying sigma, you get 0. Let us see one more question. Delta x is given a determinant of order 3 by 3 and integral 0 to 2 delta x dx is minus 16, where a, b, c, d, which are used in the determinant, are in AP. Then the common difference of AP is equals to. Options are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. Let us see the solution of it. The given determinant, by applying the transformations R2 implies R2 minus R1 and R3 implies R3 minus R1, we get this step. And given A, B, C, D are in AP, So let the common difference be p. So we can write b minus a as p and c minus b also as p and c minus a as 2p. C minus a is 2p, d minus b is 2p, and this total term we get 4p. So we get this step, and by applying the transformation R3 implies R3 minus 2 R2, we get this step, which by expanding the determinant using this row, we get minus 2p square. And integral of minus 2p square will be minus 2p square into x under the limit 0 to 2, which you get minus 4p square, which is given in the question as minus 16. So p will be plus or minus 2.